Hello and welcome back to another video. Today we're going to be going through some examples that involve nominal interest rates, real interest rates, and inflation. Let's take a look at question 1. Question 1 says Donald has 5,000 Rand. He invested into a 12-year savings account which offers a real interest rate of I for the first 6 years and 2I for the next 6 years, so that the future monetary value is 50,000 Rand. The inflation growth rate is 5%. What is the value of I, the real interest rate? So we need to note here that I is the real rate. Cool. So let's start with drawing a timeline. So at time 0, he has 5,000 and he invests it for 12 years. And after 12 years, it has a value of 50,000. And it says this is the monetary value. So let's just take note of that. So this is the monetary value. Okay, cool. And then it says for the first 6 years, it has an interest rate of I. And then for the next 6 years, it has an interest rate of 2I. So basically, the interest rate doubles after 6 years. Okay, so let's think about how we would set up an equation of value. So I'm going to move this 5,000 forward and then let it equal to the 50,000, which is the future value. So we have that 5,000, yeah. And then to move it from here to here, I'm going to just start with the real, and then I'll multiply it by inflation to adjust for that. So let's start. The real value will multiply by 1 plus I to the 6. So then that's the real value at this point. And now I'm going to move that forward another 6 years. So now we multiply by 1 plus 2I to the power of 6. Okay. So we're not quite done. This doesn't exactly equal 50,000 because these are only the real interest rates, because they said I and 2I are the real rates. We also need to multiply by the inflation, because the inflation will also increase the value. So the inflation is 5%. So we need to multiply by 1 plus 5%. And the inflation is over the whole period, so for 12 years. 12 years, and that's going to be equal to 50,000. Okay, and now what we're trying to solve for is we're trying to solve for I. So let's move all our constants to one side. So we're going to get 1 plus I to the power of 6 multiplies by 1 plus 2I to the power of 6 equals, okay, so if we divide both sides by 5,000, that'll leave us with 10 here. So it'll be 10 over 1.05 to the power of 12. Okay, good stuff. Now what we have to do is I'm going to take both sides, I'm going to raise both sides to the power of 1 over 6 to get rid of these exponents. So then we'll get 1 plus I multiplied by 1 plus 2I, and that's going to equal to 10 over 1.05 to the 12 power of 1 over 6. Okay, now let's multiply out the brackets. We're going to get 1 plus, if we multiply that, we get I, multiply that, we get 2I, so it's going to be 3I plus 2I squared, okay, and that's going to give us 10 over 1.05 to the 12 to the 1 over 6, okay, and now we want to going to solve this as a quadratic, so I'm going to want to move this across, so we're going to get 2I squared plus 3I, and if we move this across and we plug it into a calculator, I'm going to get minus 0.33134. Obviously it keeps going, but I'm just going to round it there, equals 0. And then if we sub this into if we use the quadratic formula with our calculator, we're going to get I is equal to 10.33%, or I is equal to negative 1.6. So this one is fine, but this interest rate is never negative, so we're going to say this one is not applicable. So our final answer for this one is I is 10.33%. So the real interest rate for this example is 10.33%. Okay, now let's have a look at question 2. Question 2 says a loan of 50,000 Rand was issued at time 0 and repaid at par. When they say at par, it means it was repaid for the same amount after 4 years. Interest on the loan was paid at a rate of 7.5% per annum, payable annually in arrears, okay, at the end of the year. The value of the retail price index at the applicable time are as follows. Okay, so we have the retail price index at various points in time. calculate the real rate of return of the loan. Okay, so again, let's start with the timeline. So we're going to be going from time 0 to time 4 years later. 1, time 2, time 3. So it says we take out a loan for 50,000. So our cash flows are immediately we get positive 50,000. And then after 4 years, it's paid at par. So we repay 50,000 after 4 years. Okay. And then it says interest is 7.5% payable annually in arrears. So let's work out what 7.5% of 50,000 is. So the interest is 50,000 times 7.5%. And when I put that into my calculator, I get 3,750. So we'll be paying interest. It says in arrears. So for this period, we'll be paying it at the end of the year. So at this point, so we'll be paying 3,750 here, here, and here. Okay, cool. So that's our timeline done. So it's asking for the real rates of return, and these are the money amounts or the nominal amounts. So these are the amounts that we actually get, but we want it in the real, we want the real rates of return. So we have to adjust these by the retail price index. So the way you do that, let's adjust this first one. So at time 1, the retail price index is at 209. So what you do is you take the amount, so you take 3,750, and you multiply it by the retail price index at the beginning of your period, which is 202.5, and you divide that by the retail price index at the point in time in which you are looking. So you'll divide it by 209.1. And if you put that into your calculator, it'll give you 3631.64. And I'm going to save them in our calculator as A for later. Cool. Question. And now let's do the second one. So again, we need to find the real value of this. So it's going to be 3750 multiplied by the RPI at the beginning. So 202.5 divided by 215.1, because we told the RPI at time 2 is that. Okay. Third one. 3750 multiplied by 202.5 divided by, at time 3, it's 224.2. Sorry, we need to work these out. So I'm going to plug this into my calculator, and I'm going to get 3530.33. I'll save that as B in my calculator. And then for this one, I'm going to get 3387.04. And I'm going to save that as C in my calculator. Cool. And then lastly, we just need to work out this final one. So I'll add them together. So it'll be 53,750 multiplied by at the beginning of the period divided by at that point, which was 220.4. That's going to give you 49,384.64. And we're going to save that as D. One trick that you can remember to try to remember if you should put the one at the beginning, at the top or the bottom, is since we're adjusting it for the real value, it should always be lower because inflation is going to move the price up. So after you're doing this adjustment, it should always be lower than your nominal values. So that's just a good check to see if you're on the right track with these kind of questions. Okay, so now let's write an equation of value. So all of these expenses, if we write it in terms of an equation, should equal this if we present value all of them. So if we present value all of these, it should equal that, and then we can work out our interest rate from that. So I'm going to say that 50,000 is going to be equal to our amount A, which is this one, but the real value. So it'll be A multiplied by 1 plus this to work out our real interest rate. So I'll put a little subscript R to the -1 because we're discounting it by 1 year. Now with this one, we're going to have to discount it 2 years. So it'll be very similar. So it'll be plus B, because that's the real value of this one, multiplied by 1 plus your real interest rate, the -2, plus C, multiplied by 1 plus IR. We have to discount this one 3 years, plus D, multiplied by 1 plus IR to the -4, because we're discounting both of these 4 years. 1, 2, 3, 4. Cool. So this is our equation of value. And now we just need to solve r in this. So it's going to be quite tricky to solve r in this because we have like powers of 4, powers of 3, powers of 2, powers of 1. So we're going to use a technique called linear interpolation, where we take a guess and then we slowly refine our guess using the algorithm. So linear interpolation. Okay, so I'll write out the general formula for linear interpolation. So basically, to get your next interest rates guess, you're going to take I1 plus the net present value at I1 divided by the net present value at I1 minus the net present value at I2, all multiplied by I2 minus I1. Okay. So a good guess here, you need to make sure your guesses, one of them has a positive, so your R1 should have a positive net present value and your R2 should have a negative net present value. So I'm going to take a guess that I1 is around 5%, and I'm going to say I2 is going to be 6%. So now I want to work out my net, for this formula, so we've got I1 and I2, so now we need to work out the net present value. So the net present value of I1 is going to be, all you're going to do is you're going to take this equation and instead of IR, you're going to sub in 5%. So it's going to be 5%, 5%, but then you also need to take this 50,000 across. So basically, let me just write out what we're going to do. So it's going to be A times 1.05 to the negative 1 plus B multiplied by 1.05 to the negative 2 plus C multiplied by 1.005 to the negative 3 plus D multiplied by 1.05 to the negative 4 minus, because we're moving this 50,000 across, minus 50,000. And if you sub that all into your calculator, you should get 215.54. And we're going to save that as E for our future calculations. Okay, I'm not going to write it out for the next one, but you do exactly the same thing. But now instead of subbing in 5%, you're going to sub in 6% here for R2. R2, because I guess was 6%. When you sub it in, you get negative 1470.86, and we're going to save that as F. Okay, so as we saw, this one is above 0, this one's below 0, so we want on either side, because then when it'll sandwich it and it'll slowly get closer when using this technique. So now to work out our improved guess, we're going to take I1, which is 5%. We're going to add net present value at R1, which was E, over net present value at R1, which is E, minus net present value of R2, which is F, multiplied by 6% to R2 minus R1. Cool. And when you sub that into your calculator, you should get a slightly better guess, which is around about 5.13%. And we're going to save that as M. So now we need to work out the net present value at this new interest rate to see which one we should replace. So the net present value at I3, we're just going to, again, sub it into this formula. Yeah, so basically do the same as we did here. Instead of 5%, we're going to have 5.13. And when I sub it in, I get negative 4.33. And I'll save that as X. Okay, so we can see that this is a negative. So we're going to want to replace R2 with it. So we're going to replace I2 with I3. If it was a positive, let's say it was like positive 4.33, then we would replace I1 with I3. That's how linear interpolation works. And normally they want us to do 2 steps. So this is our first step of linear interpolation. So now we're going to do it one more time. So we're going to get I4. And I4 is going to be 5%, so because it's I1, plus net present value at I1, which is E, over E minus X, because remember X was our net present value at I3, and that's all going to be multiplied by your I3, which was M, minus your 5%. Cool. And when you sub, the only reason I write letters is just because I don't want to write out the long number each time. Okay, when you sub this into your calculator, you should get 5.1278%, which is roughly, if we round to 2 decimal places, 5.13%. Okay, so let's check if we've answered the question. So it says calculate the real rate of return, and our real rate of return is, so let me just write a conclusion. So the real rate of return is 5.13%. Okay, finally, let's have a look at question 3. So question 3 says Luis Suarez is seeking a valuable investment plan to set himself up comfortably for retirement in 10 years' time. He currently has 500 million to invest, but is unsure whether to invest 80% through a bank and invest 20% in gold ingots, or invest 100% entirely through the bank. Gold has an expected market rate return of 12% per annum and is deemed resistant to inflation. Okay? Inflation is projected to be 4.5% per annum on average during the investment period. He approaches Sabertooth Bank, which offers him 2 options. Find the best course of action to maximize his real return on investment. So option A, he gets interest rate of 10%, and option B, he gets interest rate of 14%. Okay, there's quite a lot of information here, so let's maybe write a little summary of his 2 options. So for option 1, he will invest 80% in the bank, 80% in the bank, and 20% in gold. And for option 2, he will just invest 100% in the bank. Okay, and also let's write inflation. It says inflation, we often use a J for inflation. Inflation is going to be 4.5%. Okay, so now let's decide so these are the interest rates he'll get on his money in the bank, and we want to choose which one we want. So he is investing. So when you're investing, you always want the highest interest rate possible. So we're going to choose the interest rate of 14%. So the important thing to realize here is if you're investing, you want the highest interest rates, and if you're taking out a loan, then you want the lowest interest rates. So yeah, so we want to use this 14% interest rate. But this is the nominal interest rate. So we want to try get the real interest rate because we want his real return. Okay. So to get the real interest rate, the formula we use is to get the real interest rate. We're going to say 1 plus the nominal interest rate over 1 plus inflation minus 1. That's the formula. So in this case, the real interest rate is going to be 1 plus the nominal interest rate of 14% over 1 plus the inflation rate, which is 4.5% minus 1. Okay, and if you plug that into our calculator, we get 0.0909. Yeah, keeps going, and we'll save that as A in our calculator for future. Cool, so now let's work out the real future value for option 1. Okay, so the future value. So option 1 is the one where we have 80% bank. So we're going to take his 500 million multiplied by 80%. So that's the amount that he has invested in his bank account. And now we need to invest it for 12 years, I think 10 years. We have to invest it for 10 years. So if we're trying to work out the future value, this is going to be our real return. So it's going to be 1 plus A, which is your real return, to the power of 10, because you're investing it for 10 years. Okay, so that's his 80%. And other 20% in gold is going to be 500 million times 20% times, and it says that gold is resistant to inflation. So gold doesn't have any inflation, and the return on gold is 12.5%. So then we can just multiply this by 1 plus 12% to the power of 10. Okay, and if we type that all into our calculator, we should get 1,265,457,792. That's for option 1. Now let's work out the real future value for option 2. So option 2 is the one where he only has money in the bank. So the future value, we don't need to do any of this like 80%, 20% stuff. It's all going to be the 500 million. So it's going to be 500 million multiplied by the same thing, because we're moving the 500 million forward 10 years at a return of this. So it's going to be multiplied by 1 plus A to the power of 10. And when we type that into our calculator, we're going to get 1,265,457,792. 193,591,214. So we can clearly see that the real future value under option 1 is higher than the future value under option 2. So your conclusion would be option 1 has a higher future value, so he should choose that option. Cool, and that's our answer. I hope this video has helped you understand real interest rates better, and I'll see you in the next one.